So one thing we'll do with exponents is scientific notation. And the requirements for scientific notation are different than the requirements that are going to be in like your chemistry class or your physics class. So we'll talk about it for your math class, and then I'll also tell you a little bit about what you'll see in those other science classes. So what we're going to need in order to do scientific notation is powers of 10. So remembering those exponents, 10 to the third is 10 times 10 times 10. And 10 is so nice because the number here tells me how many zeros I have if it's positive. For 10 to the negative 4, we have to use those negative exponents, right? This is 1 over 10 to the 4, or it's 1 over 1, 2, 3, 4. 10,000, a 1 with 4 zeros after it. So in scientific notation, you are going to have a number here that is strictly less than 10. It cannot be 10 or bigger, and it also has to be at least 1. It could be equal to 1, but it can't be smaller than 1. It can't be 0.9. So this number here has to be something between 1 and 10. That means we're going to have one numeral before the decimal point, and it can't be a 0. So coming back to what this means here, we have 7.45, and we're multiplying it with 1,000. And when you multiply by 10, you're really moving the decimal point 1 to the right. You're making it 10 times bigger. Since we're in base 10, it's nice you just move the decimal point. So this means you're going to move that decimal point 3 times for these 3 tens. 1, 2, 3. And you fill in zeros anywhere that you had sort of those blank spaces. When you're multiplying it by something less than 1, right, 10 to the negative 4 is 1 over that 10,000. That means you're now moving it to the left. We're moving to the left, moving our decimal point to the left when we're multiplying by 10 to a negative power. So now I'm going to put my 745 over here so I have some room. I'm going to move that decimal point 1, 2, 3, 4, and fill in the zeros here. 1, 2, 3. So that's how I would write these numbers in expanded form, standard form, instead of scientific notation. Now with these numbers, they're not enormous, or they're not super tiny. It's not impossible to write these out in the expanded form. But if you had something like 7.45 times 10 to the 37, that's just not reasonable to write on your paper, certainly not 10 times. And similarly, if it was like to the negative 21, that's such a tiny number, we're going to have to write so many zeros. So scientific notation is saving us that time and effort. Now, of course, we're going to use those exponent rules to help us manipulate numbers in scientific notation. So here I have two numbers in scientific notation that I'm going to multiply, and before we solve this, let's talk about this quick. Is there any difference between 4 times 5 times 6 and 4 times 6 times 5? Hopefully you know there is not. We are using the associative property here. We can do multiplication in any order if everything is multiplication. So let's just rewrite this and put my powers of 10 together and my other little numbers together. Now I can use my exponent rules to do this, multiplying the bases, add the powers, and here I'm going to have to just actually multiply these. And here's my answer in scientific notation. Please do not write these out in standard form and multiply those and get that big ol' answer. We want to learn these shortcuts and have it go faster. All right, what about if we're dividing? Here's my question for you, friends. We have a big mess on the top and a big, not that big of a mess, but a little bit of a mess of a scientific notation number on the bottom. And instead of doing this the way it is, we're going to use the shortcuts. So here's my question for you here. 60 divided by 4 is really just 15, but stick with me for a minute. 60 is 6 times 10, yes. 4 is 4 times 1, yes. Is there any difference between like this here and this here, where I took this fraction and I like broke it into multiplying two fractions? Hopefully you know that I'm doing this same ridiculous pattern again. No, there's no difference. This is like I had a multiplication problem of fractions. I did the answer to it, right? We're going backwards. So taking this, I can do the same thing. I'm going to take this half and worry about that for a minute, and take this half and worry about that for a minute, and then at the end I'll just multiply these together. Dividing my bases, I subtract the powers, and over here I'm just going to divide those using my calculator. I'm going to keep all of those decimal places for now, but always, if a problem tells you to round, feel free to round to the appropriate place. So let's do another example here. I'm going to, since I divided my bases, I'm going to subtract my powers, and then I'll divide these guys here. This one goes on forever. I'm going to round it to the hundredths place. Now here's the part where I told you things are a little bit different in math versus in your physics or chemistry class. You will have significant figures in those classes, so what you round to matters a lot because it depends on what you have as far as those significant figures. In math, these are not measurements right now, they're just numbers out in the ether, so it doesn't matter. The rounding should be on whatever rule you are told to use. All right, one more practice with multiplying. I'm going to take my powers of 10 and add them together since I'm multiplying the bases. I'm going to use my calculator to multiply those constants out front. I'm going to use my calculator to multiply these numbers out front, and I've got 24.282. Now this should give you pause, because what did I say at the very beginning? I said this number here has to be 1 or bigger or less than 10. And 24 is certainly not less than 10. So this is not done because this answer is not in scientific notation. So what I would like to do is take this 24.282 and make it smaller than 10. I am going to divide out a 10. So I'm going to take this answer and divide out a 10. I get left with this. Here is that 10 I took out, and here is the 16 that I just brought down. So these guys now I can just smoosh together, 10 to the 17, and now my answer, oh, I missed a 2 before, didn't I? Sure did. Now my answer is in messy scientific notation. You can do this same thing if it happened to come out the other way. If you had something that was less than 1, which we know it's not supposed to be, we can borrow a 10 from over here. So I could say that this is the same as a 10, and how many are left? 4 of them. So this now, if I multiply it, becomes 8.7, which is okay for scientific notation, and we keep that 10 to the 4th.